Ben is the founder and CEO of Brale. He's also the founder at Duala. He serves on the boards of industry groups and financial institutions. He advises venture funds. And previously, he served on the Commodities Future Trading Commission.
So what I'm going to demo is going to be a bit of an extension of Chase's demo here. So I'm going to walk through what effectively our API structure kind of looks like for people that are building with it for the first time and getting used to it. And so I'll just kind of walk through a couple different ways in which you can use the Braille API and how we're kind of thinking about things as it evolves from on-chain transfers to off-chain transfers. Obviously, those are transfer types in our API structure that we think a whole lot about. As you look at our API, basically there are two meaningfully different APIs that we offer. One is a data API, which you can utilize permissionlessly to get access to information about different stable coins, even almost as a really lightweight, almost Oracle type thing. And adding these stable coins to the data API is as easy as adding it to the Commons repo by adding a token list. And so these can be added permissionlessly really easily. Obviously, someone has to release or approve a pull request, but it's an easy way to add new stable coins and get access to some mild feature functionality that can be really helpful for LLMs and things like that. The API that Chase is demoing is our transfer API. And to use that, you have to get an access token, and then actually utilize the transfer endpoints to move actual money. But I wanted to share some of the things and concepts that make it a little bit easier to use and think about as you start building with it. Obviously, authentication is one big thing, but accounts and addresses is something that's meaningfully important to understand in the API structure. And so what Chase is showing is that you have access to a set of API keys. An API key has an account ID. An account ID in our system is tied to internal and external addresses. Each external address or internal address is tied to a specific type of blockchain or transfer type. So a transfer type could be something like Spark. A transfer type could be something like ACH debit. It's meaningfully versatile. And so as we kind of think through how these things play together and how you build your instructions, I'm going to use a really lightweight Braille MCP server that was actually built by the SBC team. We'll see how this works. So obviously it's going out, grabbing an access token via the auth endpoint, coming back. What is my account ID or my custodial account? And I'll explain why I'm actually going to retrieve the account ID in a minute. It's meaningfully important to the URLs that you're going to submit requests to. So the account ID is used in each individual request. As Chase is showing the actual transfers. My account ID here, I've got two IDs on this particular account. One is a test account, one is a main account. And so as I'm going through and creating a transfer, you're going to want to use the account ID in the instruction. And so that account ID is associated with the accounts that that particular set of API keys can interact with. So in this case, if I wanted to utilize that account ID, I would use it here in an example instruction. And so if I wanted to then, let's say, move money from USDB on Spark, which is what Chase was just demoing, to even like an SBC on Canton, just for the sake of time, let's see. What you can see is that hopefully what ends up happening is the system actually just routes over Spark, the burn. Oh, that sucks. Live demos. I feel like Ethan probably empathizes at the moment. There we go. So effectively what ends up happening is the system normalizes the instruction to burn on Spark and mint on Canton. And what's really exciting about that is effectively then you can go from hyper throughput, hyper speed on-chain transactions on Spark to privacy preserving state on Canton. And so what we see is a lot of payments companies really tend to love this and start to think about, oh goodness, well, if I want to, let's say, start with privacy preserving state on Canton, and I want to, let's say, move to a large scale payout on Spark, it goes both ways. And so the API itself is extremely, extremely versatile. And you can basically implement these instructions across any blockchain or anything else that we've implemented. So this could be a source on Base. This could be a source on, you can imagine, this could actually be ACH debit, where this is USD. And suddenly you can start to think about, well, what happens when all off-chain bank accounts become in one API endpoint usable with all on-chain transfer types and vice versa. The number of workflows becomes a little bit mind-numbing, but that's one of the benefits to the actual API design is that on-chain transfer types are just transfer types with address IDs. Off-chain are the same. And so as you think about building with the product, account IDs also have something called financial institution IDs, and these are designed for first-party transfers. So if my company is putting money into my own custodial wallet, that's a first-party transfer. But these other designs are more for second and third-party transfers, which you'll start to see more documentation for in our API, hopefully in the coming weeks. This gives us one API endpoint to have composability between all on-chain and off-chain transactions without developers ever having to think about using things like an ISO standard or Solidity or Rust or something else. The money just goes where it needs to go. And every time we bring a new ecosystem online, just like Spark, everything is reverse compatible with everything else. Happy building.